Alright guys, on today's episode, just kidding, we're going to go over 35 through 40, second exit ticket of the week. So, passage 7. Straight to the question, based on the results of experiment 1, so that's where I'm going to be looking. If the concentration of F minus is doubled, this is IOD, then the conductivity will what? So, let's go to experiment 1. And the concentration is going to be doubled. So where does that happen? From 1 to 2 and 2 to 4. Let's see, is it the corrected conductivity or the measured conductivity? It's corrected. So the corrected conductivity will. So from 1 to 2, it went from 1.7 to 3.3. And from 2 to 4, it went from 3.3 to 6.6-ish. So that looks like it is also doubling. So the answer to 35 is C. All right, 36. A sample was also taken from the drinking water supply of the community of Bluewater in experiment 2, and its conductivity measured to be 20.69. Which of the following correctly lists, this is also IOD because you have to list them out, list the drinking water supplies of Newtown, Lakewood, and Bluewater in increasing order of F minus concentration. So, concentration of F minus, increasing order. So here we have, let's see, is there a trend here? So let's first put this down here. 0.3, 16.46. 1.6, 18.63, 2.1, 19.47, and 3.8, 22.31. So 20.69 is going to weasel its way right in here. So that will be right here. So that is, what is it, Bluewater? Blue. So this one, the smallest one, is Springfield. And then we have Lakewood. Then we have Reading, right? Lakewood, Reading, those are 2.1. Then we have Bluewater. And then we have Newtown. I'm running out of space. So that way, that way, that way, that way. Okay, so what are our options? Lakewood is the smallest here. So, and then it goes to Reading, which is not on our list. So then it should go from Lakewood to Bluewater. So that's this one. J. So that one has a couple steps, because first it was like figure out where the 20.69 falls. So reorder. I'll write this down in the yellow. We reorder, fill in Bluewater with the 20.69, list them out. That doesn't say listen spelled wrong, it says list them out. And then for compare. Alright, 37. Based on the results of experiment 1, so I'm going to look at experiment 1. If a solution with a concentration of 3 had been tested, the corrected conductivity would have been closest to which? That's an IOD question again, it's interpolating. So, let's say conductivity of 3 had been tested. So 3 fits in between 2 and 4. And I'm again looking at corrected conductivity. Mosey over to that way. So it's going to be between 3.34, answer, and 6.68. Nope. Too small, too small. Alright, now we have 3.34, answer, and 6.68. So which one is it going to be, 5 or 6.5? 3 is directly in the middle of 2 and 4, and 6.5 is too close over here. So the answer is C, because that's more of a middle ground. Alrighty. 38. Can't count. 38. If experiments 1 and 2 were repeated to measure the concentration, this is SIN. Anytime it talks about it repeating an experiment, it's SIN. Okay, if experiments 1 and 2 were repeated to measure the concentration of chloride ions in drinking water, I apologize for that. So, which of the following changes in the procedure would be necessary? Now we need to go back to the procedure. 5 solutions, each containing a different amount of Na2SiF, were prepared. Blah, blah, blah. The cells were activated to measure the conductivity for each. The conductivities were then corrected by subtracting the conductivity. Okay, and we're using Na2SiF. So in experiment 1, Na2SiF. In experiment 2, the cell was activated. It doesn't say anything about what we used. Okay. The solutions in experiment 1 should be added by different concentrations of NaCl or another. That sounds like a good thing if we want chloride ions. The conductivity of the blank solution should be added. That doesn't put chlorine in our sample. Resistivity, that has nothing to do with chloride. Both NaCl and Na2SiF should be added to all of our samples. Okay, so we're between F and J for this one for 38. So it's not J, and this is because that's not controlled. That's 2 independent variables right there, and we don't want that. We only want to test chlorine, so the answer is F. Only make one change. Only make one change at a time in these. Okay, 39. Based on the results of experiment 1 and 2, if the measured conductivities for the samples tested in experiment 2 were compared with their corrected conductivities, the measured conductivities would be. So, we're going to go to experiment 1. What this is asking us to do, this is again IOD, is find a relationship here between measured and corrected. So, measured is higher across the board. So measured is greater than correct. So let's go back here. So this is your measured. So if we had the corrected conductivities, right? They would be the measured conductivities would be, so make sure you know which one you're talking about, because in this question we're talking about measured, and it would be higher. We found out that they were higher. So 39 is B. All right, and our final question. The presence of other negative ions, such as Cl-, results in an increase in the electrical conductivity. If all the samples contain trace concentrations of Cl-, how would, so this is SIN because it's how would it change? How would results change? Okay, if all the samples tested in experiment 2 contain trace concentrations, you can't even see what I'm writing, trace concentrations of Cl-, how would measurements have been affected? So compared to the actual F- concentrations, the F- concentrations apparently measured would be. So this is saying that Cl- increases the conductivity, right? And our conductivity comes from concentration of F-, the higher it is, the higher the conductivity. So if you go to experiment 2 here, you see the higher the F-, the higher the conductivity here. So if you up conductivity, and that's from experiment 2, you increase F-. So if they all had Cl, then all samples would also increase. All my arrows are pointing the same way, increase. And that's about it.